All right, we were just talking about trapezoids, and we're going to go a little bit farther into that and actually talk about something special called an isosceles trapezoid. So an isosceles trapezoid is a very special trapezoid. The two legs or the two non-parallel sides are congruent. So our legs are congruent. That's these suckers right here. This is a leg and this is a leg. The two non-parallel sides. Also, our base angles are congruent. So when I say base angles, I mean the angles that are using the same base. So this angle down here is using the same base as this angle. So these two are congruent. And the top base angles are congruent. Now remember, trapezoids, the two bases are parallel. So we need to remember that this base and this base are parallel. So we have base 1 and base 2. And the 1 and 2 doesn't really matter. It's just to keep them straight of each other. And then also, if we create diagonals, those diagonals are also going to be congruent. So if I cut a diagonal here and a diagonal here, these are congruent to each other. So lots of congruent things. Another thing that you have to keep in mind, so we talked about earlier with trapezoids that angles that are using the same leg from the two different bases are supplementary. So if I go around and name these, I'm going to rename my angles. I've got A, B, C, and D. We previously knew, so previous knowledge is that A plus D would equal 180 and B plus C would equal 180. But since A and B are congruent and D and C are congruent, I'm going to put new knowledge, different colors. New knowledge is that your opposite angles are going to be supplementary. So think about substitution. If A is congruent to B or equal to B, then B can be also supplementary. So B plus D equals 180, and A plus C equals 180. So that's us saying opposite angles are supplementary. So lots of good stuff we're getting from this. And then, of course, remember, all the angles in a quadrilateral, as we discussed yesterday, have a sum, an internal sum of 360 degrees. So let's see how this gives us more information to solve for, but it also gives us more information that helps us solve our trapezoid, since we have things that are congruent. And we always want to make sure, how do we know it's an isosceles versus a non-isosceles trapezoid? Well, we look at the legs. These are our two legs. They're both equal to 6. Does that make them congruent? It absolutely does. So this is isosceles trapezoid. And because of this, I can find the measure of angle K. These two are opposite, and opposite angles are supplementary. So if opposite angles are supplementary, the measure of angle K is equal to 100 degrees. Looking at my next example to the right, these are congruent, these are congruent. So again, this is isosceles. Can't spell today. Isosceles trapezoid. And opposite angles are supplementary. So the measure of angle Z we take 180 minus 82. That's going to give us 98. It's 98 degrees. All right. Now we have triangles or trapezoids. Trapezoids. We're going to go on the assumption. We are going to assume, because I am telling you, this is isosceles. Like it tells you on your formative, like typed in, but didn't accidentally didn't put it on this paper. But we're going to assume it's isosceles. If it's isosceles, these are called base angles. So angle R and angle Q are base angles. And what did we just talk about with isosceles trapezoids and base angles? Because they share the same base, base angles are congruent. So if they're congruent, then they're equal to each other. So the measure of angle R is equal to the measure of angle Q. We've got 10n plus 19 equals 12n minus 4. And we're just going to solve for n. Move some things around. Add 4 to 19, we get 23. And when you divide that out, so n is equal to 23 over 2, which is the same as saying 11.5. And then so if we are assuming that these are isosceles, we're going to put this here and this here. We're going to do the same with our next one. We are also going to assume, because I am telling you, obviously that won't happen on like a quiz or a test. It will state it either by marking the sides of the trapezoid as congruent, the two legs, or it will state it in the question, like trapezoid is isosceles. So please remember that. Okay. Now, these are opposite angles. These are not base angles, the two that are given, H and F. These are opposite from each other, and we just talked about this again. Opposite angles are supplementary. So I can take x squared minus 10 plus x squared minus 98 equals 180. Combine my like terms, and I have 2x squared minus 108 equals 180. Move that 108 over, and I'm left at 2x squared equals 288. I'm going to bring this up over here. Divide by 2, and we have x squared equals 144. And square both sides, square root both sides, you get x is equal to plus or minus 12. Remember, if you get a negative, you need to double check. Just like we did previously last semester within the past unit, double check that it works, because the positive is going to work, obviously. But you got to double check that negative. Since we're squaring it, what's going to happen to a negative 12? It's going to turn into a positive 12. So it will work. Negative 12 squared is 144. 144 minus 10 is 134 positive. So it works out beautifully. All right, we have another isosceles trapezoid. It tells us that we're trying to prove, okay, I'm running out of time. I'll be back shortly.